grade 11, you have good health and a nice time for your holidays. For today we will go to we are going to talking about the ideal gas law in chapter 5 section 2. The ideal gas law is the mathematical relationship among pressure, volume, temperature and pressure. I think we studied this relation in previous lesson. Then the ideal gas law in chapter 5 section 2. Chapter 5 section 2. The ideal gas law is the mathematical relationship between pressure, volume, temperature and the amount of substance or the number of mole of gases. The derivation of the ideal gas law is derived from three laws. These three laws is Boyle's law and Charles' law and Gay-Lussac's law. And Avogadro's law. In Boyle's law, the relation between volume and pressure at constant temperature. The Boyle's law said that the volume of fixed mass of gas inversely proportional to the pressure at constant temperature. V is inversely proportional with pressure at constant temperature. And in Charles' law, the relation between volume and temperature, Kelvin temperature, says that the volume of a fixed amount of gases directly proportional to the Kelvin temperature, proportional to the Kelvin temperature. And the Avogadro's law is the relation between volume and the amount of substance or the number of moles, also directly proportional. The volume of gas directly proportional to the amount of gas at a given temperature and pressure. Okay. By using the three previous law of gases, we can get or we can obtain the following relationship. V is inversely proportional according to Boyle's law. V is inversely proportional according with pressure according to Boyle's law, and volume directly proportional with temperature according to Charles' law, and volume is directly proportional with the number of moles according to the Avogadro's law. Then we can change the proportionality. This sign is named by proportionality. By changing this proportionality to the equality, changing this proportionality to the equal. Then by introducing the constant, in this case, so we must use the constant and the using constant is named by or symbolized by R. Symbolized by R capital, not small. Here look at P is capital, T is capital, but N is small. Also R, then we can say V is equal to R multiplying by changing this proportionality to the equality. This by using constant. This constant is symbolized by R. Then V is equal R multiplying by 1 P multiplying by T multiplying by N. The equation, we can rearranging the equation, we can get this relation V is equal nRT over P, or we can say equal PV is equal nRT. Okay, V is volume, N is the amount of substance or the number of mole, R constant. How we can obtain, or how we can get the R value at STP. The ideal gas constant, we can using the above relation, the relation PV is equal nRT. Then we can say the ideal gas constant is equal PV over NT. P is pressure at standard temperature at STP, at standard temperature and pressure. Pressure is 1 atm, and the volume at STP is 22.440 liter, and N is equal 1 mole, and the temperature in Kelvin temperature is 273.50 Kelvin. By dividing these two value, we can get the R value is equal 0.082 or 5784 liter atm mole Kelvin. And we can, the value of R is, we can round it, is usually rounded to 0.082 liter atm mole per mole Kelvin. The unit of gas constant depend on the unit of pressure, volume, and the mole and Kelvin. Okay, the ideal gas law can be applied to determine the existing conditions of gas sample when 3 or 4 variables PV, T, and N are known. One of them must be unknown. It can be used to calculate the ideal gas law. PV is equal nRT. We can use to calculate the molar mass or the density of any other gas sample. Now let's solve some practice by using the ideal gas law. For example, if you have the following question: what pressure in atmosphere needed? The pressure in atmosphere, this is the unit of pressure, is exerted by 0.325 mole of hydrogen gas in a 4.08 liter. This is the volume, because the unit liter for volume, and this is mole in a container at temperature 35 Celsius degree. Pay attention to this point, dear students. If in the question, in any question, the temperature given in Celsius degree, you must convert it to Kelvin temperature. How we convert Celsius degree to Kelvin temperature? By using the following relation. Kelvin temperature is equal Celsius degree plus 273. Then Kelvin temperature is equal Celsius degree is given in the question 35 Celsius degree plus 273, which is equal 308 Kelvin. And needed what in the question? Ask about the pressure in atmosphere. We use the ideal gas law, PV is equal nRT. Needed what in the question? Ask about how we can find the pressure in atmosphere. Then we can convert the relation, the same relation, P is equal nRT over V. N is equal, given in the question, 325 mole. Here we substituted N is 0.325, R 0.082, T is Kelvin temperature. We converted this Celsius degree to Kelvin temperature. We substituted here 308 Kelvin divided by the volume of container, which is equal 4.08. So the final answer is pressure is equal to 0.01 atm. The pressure must be in atmospheric pressure. This is depend on the atm, the unit of in the Kelvin in ideal gas law. Okay, dear students, for you we have an homework by using the same relation, and we convert the Celsius degree to Kelvin temperature by using. This is homework for you. I have to solve it at home. I think you have an extra time to solving the question if you liked. Please, let's resolve another kinds or another types of question. A sample that contains 4.38 mole. This is number of mole as gas at 250 Kelvin. Here this temperature is not in Celsius degree, directly given in Kelvin. In this case, and this type of question do not need it converted to Kelvin, because directly the temperature is given in Kelvin, and the pressure of the gases is equal 0.857 atm. What is the volume? Here needed volume. By using the following relation, V is equal nRT over P. N, the amount of substance in mole, 4.38 given here. This is the number of mole substituted here in this by N. N is equal 4.38 mole, and R is equal 0.082. This is the R value, and temperature in Kelvin 250 Kelvin, and the pressure is 0.857. By dividing these two value, you can get the value of volume is equal 104.77 liter. Please, dear students, I hope to solve this type of question by using the same relation, above relation. V is equal nRT over P. Only here we have the Kelvin, the Celsius degree is not Kelvin temperature. Here in Kelvin temperature, in above question in Kelvin, do not need it to convert it to Kelvin, but in this type of question you must convert it to Kelvin temperature by adding this number, or plus it to 273. This is homework. Let's solve another kinds or another type of question. How many grams in these types of needed, or we can use the ideal gas law in order to find the mass of substance. Grams, grams, the unit of mass. Needed mass here in this question, needed mass. How many grams of carbon dioxide gas are there in 40 5.1 liter container at 34 Celsius degree and the pressure 1.04 atm. Dear students, pay attention to this point. Here we have this is volume, this is temperature in Celsius degree. Directly you must convert this Celsius degree to Kelvin temperature by using this relation. Kelvin temperature is equal Celsius degree plus 273. 34 plus 273, the final answer is equal to 3. This is the Kelvin temperature. The Kelvin temperature is equal 307 K. K, and it means Kelvin. Okay, needed what? Grams. Grams, it means mass. Mass is equal PV multiplying by molar mass of carbon dioxide. I think you know how we find the molar mass of carbon dioxide, because we studied in first course how we find carbon dioxide. The chemical formula, or the chemical formula for carbon dioxide is CO2. CO2, molar mass of CO2 divided by RT, gas constant, and Kelvin temperature. M is equal P given 1.04 atm multiplying by the V is given in the question 45.1 liter multiplying by molar mass. You must know how we find this number 45. Carbon dioxide CO2, 1 carbon multiplying by 12 plus 2 oxygen CO2, 2 oxygen multiplying by 16 equal 32 plus 12, which is equal 44 gram per mole, and the amount of R, or the value of R, is 0.082 multiplying by 307. The final answer will be mass is equal 81.9 gram, or we can round into 82 gram. Dear students, for you, this is homework. What is the mass in gram of oxygen gas in a 12.5 liter container? Here the container is 12.5 liter container at 45 Celsius degree and 7.22 atm. This is pressure, this is Celsius degree. By using the above relation converted to Kelvin temperature, then and volume, needed mass is equal PV multiplying by molar mass. Molar mass of oxygen is equal to 32, because one oxygen atom is atomic mass is equal 16. 2 oxygen, 2 times 16 is equal 32. Then you can find the mass of oxygen gas in this condition. Hope you to take a nice time about the chemistry lesson. Goodbye.